Today's video will be about the product rule, which is our next exponent rule. This is used for multiplying monomials. So you can see here we have x to the third power times x to the fifth power. And we are going to use the product rule to get a simplified answer. So what this really means is we have x times 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 x. So we've got 3 times 3 x's times 5 x's. So we have to think about altogether how many x's do we have? 1, 2, 3, 4, 5, 6, 7, 8. So we have x to the 8th power as our answer here. Well, the power rule says, well, instead of going through all of that, we could have just done x to the 3 plus 5 power and gotten x to the 8th power instead of writing out all of these x's. So the rule is if you have x to the a times x to the b, then you have x to the a plus b power. Now this is only true if the base is the same. So they both have to be x's, or as you look in these problems below, you know, they both have to be r's or b's or y's. So to get to use the power rule, the base, the big number or variable, has to be the same. All right, so let's do a few of these. I'm not going to do them all. The ones that I don't do, you guys do, and we'll go over in class. So this first one is very similar to the one we've already looked at. You're just going to do 3 plus 2, which is 5. You're done. The second one, I want to point out something. So what you have here is you have y times y times y times y for y to the 4th times another y. So that's really y to the 5th because you have 1, 2, 3, 4, 5 y's. So for the product rule to work here, you have to remember that that's y to the first power, so that you do 4 plus 1 to get this 5. Okay, so make sure that you're paying attention to that when you're doing these problems. For number 3, yes, you can have fraction exponents. So fraction exponents, though, aren't treated any differently. You're still just going to add them together. So you can see here I'm setting that up. Oops. Oh my goodness. I don't love this calculator. So you're going to do the same thing. Like previously, in the previous problem, I did 4 plus 1 and got 5. In this one, I'm going to do 1/2 plus 3/2, and I'm going to get 2. So sometimes if you add the right fractions together, you do get a whole number. So this one would just be x squared. That's it. That's the answer. Now, if you're doing negative exponents, you're going to do the same thing. So for this first one, we're going to do -2 plus 9. I encourage you on these ones with negatives to use your calculator. So that would be 7. On this next one, I would do 5 minus -8. Or, I'm sorry, 5 plus -8. What am I doing? So that would be -3. Now, remember back in the first video, we said we couldn't have negatives. So this is actually going to be 1 over b to the 3rd. Okay, so be careful about that. Then in this second one, or the 6th one, I'm going to do 4 plus -1/2. So type it in like that. And it's going to give you 7/2. And that can be your answer. It's positive, so I don't have to move it. I don't have to change it. The answer really can be y to the 7/2. So it's kind of hard to like this doesn't necessarily look like an exponent, if you have room, try to make sure that your variable, is bigger than the fraction. All right, in this next section, it's kind of putting multiple problems together. So we have an x and a y times another x and a y, a b and a c times another b and a c, and so on. Your job is to make sure that you are multiplying x times x and y times y. Now your answer is going to be xy, but you got to make sure that you don't jumble up the exponents when you're adding them together. So for this one, I'm going to do 3 plus 6 and get 9. And then for y, I'm going to do 4 plus 2 and get 6. And so my answer is x to the 9th, y to the 6th. Okay? Same thing with number 8. I'm going to have b to the 7th because 8 plus negative 1 is 7. And then I'm going to have c to the 4th because negative 3 plus 7 is 4. Now, sometimes you'll get one like number 9. Number 9 has a little sneaky thing in it. So first I'm going to do x and x. So I'm going to do 2 plus 3 and get 5. And then I'm going to do y and y. So 2 plus negative 2 is 0. We'll come back to that. And then for z, I've got 2 plus 1. And if you need to write the 1 there, do it every time. 2 plus 1 is 3. Now, if I have y to the 0 power, that just means y is 1. So 1 times x is x. So I'm just going to have x to the 5th power, z to the 3rd power, and that's going to be my final answer. I don't like that. That cut off my tops. There we go. Okay, so if you get y to the 0 power or anything to the 0 power, remember that's just a 1. All right, the next one, those you're going to put the two m's together. The n's just going to hang out the way it is. Let's do 11 because it has a lot of negatives. And then I'm going to leave 10 and 12 for you guys to do. So in 11, we've got r to the negative 5th and r to the negative 1. So I've got negative 5 plus negative 1. So that's negative 6. Then I've got s to the negative 3rd times s to the 6th. So that's going to be negative 3 plus 6, which is 3. This r to the negative cannot be part of our answer. So I'm going to rewrite this and move it to the denominator so that it can be positive. Okay? So when you move it, it changes it from negative to positive. Remember I talked about the negative is just telling you I'm in the wrong place. I need you to move me. All right, so 12 is kind of like a combo of 11 and 9 or 11 and 8. So do that one. And 10 is also kind of like 11. On the next page, we've got the product rule with coefficients. So when you have the product rule with coefficients, you have to keep the coefficients separate. So you are going to do something with the big numbers and then something with the exponents and variables. Okay, so it's like having two different problems put together. So what you do with the coefficients is you just multiply them. This is, after all, just a multiplication problem. So 2 times 8 is 16. And then you're going to use the product rule with the x and the exponents. So 3 plus 5 is 8. So you have 16x to the 8th power. So you do the coefficients first, then you look at the base with the exponent. So the rule for that, when multiplying monomials, you do multiply the coefficients, but you add the variable exponents. So make sure that you keep those straight in your mind. This next section just has some mixed problems with coefficients and variables with different exponents. So I'm going to do a few of them, and then you guys do the rest, and we'll talk about them in class. So let's start with number 1. Number 1 is a lot like the one we just did. You're going to multiply 6 times 2 and get 12, and then add 3 and 6 to get the exponent of 9. If you have one like number 2, you're going to multiply 4 times negative 6 and get negative 24. Remember, the coefficient can be negative, just the exponent cannot be negative. So don't move coefficients just because they're negative. They're fine. And then we've got negative 2 plus 1. Okay, because this is a 1. So that means we've got y to the negative 1 power. Well, we can't have that. So this part and this part only does need to move to a denominator. The negative 24 does not have a negative exponent. It just has a negative. So it doesn't need to move. So it's actually y to the positive 1 power. But remember, y to the positive 1 power is just y. So you do not have to have that exponent there. Okay? Let's see what else we have. Let's look at number 5, because it's got those zeros. So I want you to be sure you understand what's happening here. So b to the 0 power is 1. So you have negative 2 times 1 times b to the 0 power is 1. But you've got this negative, so it's negative 1. So you have negative 2 times 1 times negative 1. So you can literally just put that. Why am I hitting the wrong button? So you can just type that in and get the answer of 2. So sometimes you just get a number. And this should make sense to you because the b's have essentially been zeroed out. So you shouldn't have any b's when you get done. All right, let's look at number 6. So number 6 has a negative x. Well, what that really means is the coefficient is negative 1. So what we're really doing in the coefficient step is negative 1 times 2 times 5. So you're just looking at these big whole numbers. So that's negative 10. Then we're going to look at the exponents. So we have 4 plus negative 2 plus 1. Don't forget, there is a 1 there. So there's a 1 here and there's a 1 there. So when you put that in there, you're going to get 3. So it's positive exponent. You don't have to move anything to a denominator. All right. In number 7, we have some coefficients. We have some negative exponents. We have some x's. We have some y's. So let's do that one. The first thing, just like before, we're going to start with multiplying these coefficients. And you know they're coefficients because they're big whole numbers, not little exponents. So 2 times 4 is 8. Then let's look at x. So we've got negative 6 plus 4 for the exponent on x. So that's negative 2. Then let's look at y. We've got 6 plus 2, which is 8. So everything's in good shape except for that negative exponent. So the negative exponent and its base, which is only the variable, has to move to the denominator. So 8y to the 8th gets to stay on the numerator, and x squared has to go to the denominator. All right, so there's that one. Let's see what else we've got here. Let's look at number 9. Number 9 has a couple of coefficients. So it's got 6, negative 2. So we're going to do 6 times negative 2, which is negative 12. Whoa, got a little carried away. Then we're going to look at x. So the exponents for x are 3 and negative 4. So we're going to do 3 plus negative 4. That's going to be negative 1. We'll come back to that. Then we're going to do y. Well, there's only one y, so there's nothing to add to its exponent. We're just going to keep it the way it is. And then z has 6 plus 1, so that's 7. So don't forget about that being a 1. And then for this one, the x and the y both have negative exponents, so they both have to go to the denominator. Negative 12 does not have a negative exponent, so it can stay in the numerator with the z. And then we have x to the negative 1, so that's going to become x to the positive 1. I don't need to write that 1. And then y to the negative 4 is going to become y to the positive 4. So this is our answer for that one. All right. It looks like 10 is kind of like 9, and let's do 12, because 12 is set up a little bit differently with parentheses. Sometimes they do have parentheses instead of the dot. This one, you don't have another number other than 1. So 1 times 3 is just 3. And then remember, you need to put your letters in alphabetical order, so you need to put R to the 4th next. And then S, you've got negative 6 plus 6. Well, that's 0. So I don't actually need that, because that's just another 1. And 3 times 1 is just 3. So that is my final answer for that one. Let me look at 12 a minute. 12 does kind of have a lot going on, because it has this like B times B business. But I want you guys to try it, and we'll talk about it in class.